For over 40 years, physicists have argued about a strange fact. Galaxies do not rotate the way Newton says they should. The outer stars move too fast. Either there is a vast invisible halo of dark matter holding them in, or gravity itself works differently when accelerations get small. The second idea is called MOND, and depending on who you ask, it is either the most predictive framework in galaxy physics or a clever recipe that happens to fit the data. Frankly, nobody has been able to settle that argument because nobody has proved that MOND's core equation has to look the way it does. Until now. A new monograph just dropped by USDX Research called Classical MOND Foundations. It proves three things, and they fit together in a way the field has never quite stated before. First, inside a clean set of mathematical assumptions, the MOND field equation is not chosen. It is forced. The cubic operator that sits at the heart of MOND turns out to be the only one that works. The famous galaxy scaling law, where mass goes as the fourth power of rotation speed, falls out with no fit parameter. Second, the same equation that controls how stars move also controls how light bends around galaxies. Not by assumption, by theorem. The deep MOND lensing law matches what general relativity gives you for a galaxy with the same rotation speed without needing dark matter to do the bending. Third, the paper's strangest prediction, that a galaxy's internal dynamics depend on the gravitational field it sits inside, is not an extra rule. It is a structural consequence of the same operator. And it leaves a fingerprint, a 2-to-1 anisotropy along the external field direction that the operator's exponent locks in. That fingerprint is testable. So here is what changed. Motion, light, and environment are not three separate MOND results stitched together. They are one operator and two theorems about its closure and its boundary. The classical foundation of MOND now has the rigidity of theorem, not the elasticity of a recipe. This paper does not solve cosmology. It does not refute dark matter. It does not handle galaxy clusters. Those are separate problems. But it does prove this. The classical low acceleration spine of MOND is mathematically rigid in a way nobody had quite seen before. Standing on the work of Milgram, Bekenstein, Sanders, Fame, Magat, Lely, Skordas, Banach, Zhao, and Che, this monograph settles a question the field has been circling since its inception. The link is below. If you have ever wondered whether MOND is physics or numerology, this is the paper that draws the line.